When atoms gain or lose electrons, they become charged particles called ions. So an ion is a charged particle, plus or minus, positive or negative. Positive ones are called cations. I know it doesn't look that way, but I promise I am not misleading you. It is called a cation. If you want to make people think you're a newbie, say cation. You will look like you are from way out of town. And the negative ones are called anions. There is a reason for this, is because these were attracted to the cathode and these are attracted to the anode. You want to discuss what that is? Take AP. With charges, we can use the phrase that opposites attract. They can make pairs and groups. They make neutral particles overall. So they make neutral, that's charge 0, particles overall. For instance, Na plus can attract Cl minus to make table salt with the chemical formula of NaCl. So that would be +1 and -1. And so the answer overall is charge 0. Total positive charge must be equal to the total negative charge. If the ionic formula has a charge of +2, then there also is a charge of -2. Look at the periodic table at the left and right edges for 2 columns at the left and the 4 columns at the right. There are notes. Noble gases are called noble because they are chemically inert. There is a fine word for you, and it means unreactive or inactive, and they won't react with anything. Under the trough, that's the dip down, there are the transition metals. Where the charges don't make a pattern. So kids ask me, what do I do about the charges way down there in that big space down here? And the answer is you look it up on the back. That's why we have that. I've never discovered a pattern down at under the trough. This is why you have an ion chart on the back of your periodic table. Transition metals can be looked at there. So the number of atoms in the formula is written as the number at the lower right of the element. For instance, if we have 2 sodiums with 1 oxygen, we get 2 sodiums and 1 oxygen. The breakout is here. The 2 goes with the symbol on the left, so that's 2 sodiums and 1 oxygen. We don't write the 1 on the oxygen. Again, I guess you could. You could put a 1 there if you want to, but it makes you look like you are really new. No one puts the 1. Self-test, find the formulas for sodium with fluorine. That's Na plus with F minus. We need to get a neutral, but you know what? +1 and -1 already works. It's already neutral. Potassium, look on your periodic table, is +1. Chlorine is in the -1 column. That already works. So it's just KCl. Mind you, I am writing in the charges here just because I want to be helpful. The real answer does not have the charges. It would truly be NaF and KCl. I know that's a lot of erasing in a high school class, so I don't really want to argue about that too much right now. If you leave the charges in, I will allow it. But note to all you future chem college students, you might actually get marked down in a college class for leaving it like this, because really the charges are not included when the overall answer is charge 0. So magnesium is a +2 and oxygen is a -2. +2. That adds to 0 already, so that's fine. Aluminum with nitrogen, aluminum is, let's put it here, Al, and it's a +3. Look on the periodic table. It's in the +3 column here. And nitrogen is in the -3 column. That adds to 0, so let's just leave it. So one of these and one of those already adds to 0. Calcium with iodine. Okay, here we go. Here's where it gets a little bit more complicated, a little. Calcium is a +2. Look at the left side of your periodic table. And iodine is a -1. So we cannot just leave it alone like that. We can't change the charges. That is not allowed because that is just simply a fact. This is a +2 and that's a -1. You can have more than one of them, though. You can have 2 of those, and then we would have 2 -1s and 1 +2, and that would add to 0. Beryllium with chlorine. Look over on the left. Beryllium is plus 2. Chlorine is minus 1. So we need 2 of those so that this adds to 0. Sodium with sulfur. Well, Na, look at the left, is plus 1. Sulfur is in your minus 2 column. And so this time we will need 2 of the positive thing, because it's like that. We will have 2 of the thing that is positive 1, and invisible 1 of the thing that is negative 2. Lithium is a positive 1, look left. Phosphorus is a negative 3, so we will have 3 of the positive 1 lithiums, so that this now all adds to charge 0 overall. If we have iron, Roman numeral 3, we have iron that is plus 3. So that's the pattern. So if they tell you a Roman numeral, they are telling you the charge, which means if we have iron 2, we have iron that is positive 2. And I know I just said this, but I get kids who weren't totally paying attention, and they think that the Roman numeral means how many irons or nickels or something we have. No, it's the charge. Why would you need to do that? Every time we looked, I didn't have any doubts about the charge, because down here, under the trough and down in here and so forth, the charges get really wonky, and there is very definitely a possibility of having something that has more than one charge. So you can't just say iron, you have to tell me which charge. I can't just say lead, I have to tell you which lead. So we state that in the Roman numerals when we are writing it out in English words. We will say the charge in a Roman numeral if we're trying to indicate which charge it is. Now, why didn't we say that before? It was never in here because magnesium only has plus 2 charge. It's not down here. And there's no doubt that magnesium is a plus 2. Also, I will point out, zinc only has plus 2, so I don't need to say zinc Roman 2. I don't need to do that because you can look it up. Zinc is only plus 2, so I shouldn't have to tell you it's plus 2 when I write out the name. You can go look it up and say, oh, it's only plus 2. Silver is only plus 1, so I will not say silver parentheses Roman numeral 1 because silver is only plus 1. You can go look it up. So if I say silver and you look it up, you'll say, oh, I guess I do know what the charge is, and we don't need to use the Roman numerals. So the Roman numerals, note to self, is when the charge is in doubt because there is more than one version. Hit pause and write that down. These notations are made for elements that have multiple possible charges. These all will be in the transition or other metals, because the other metals are the ones down here, and there are multiple charges of things like tin and lead. I know lead. Is there tin? I'm almost positive. Yes, there are multiple charges. There are 2 possible charges on tin. There we go. Sometimes we get a situation like lowest common denominator with Cr plus 3 and O minus 2. The whole number that 2 and 3 can meet at is 6. We will get Cr2, so that positive charge is positive 6. Remember, there's a plus 3 in here, right? And O3, so the negative charge is negative 6, because remember, there's a negative 2 on that. So what we have is 2 sets of plus 3, which is positive 6, and 3 sets of minus 2, which is negative 6. And then the whole particle is charged, as we said before, 0 or neutral, if you want, neutral. Anions that are just on their own get named "ide." So sodium, or NaCl is sodium chloride. Why is it chloride? Because there's just Cl's. And the point is not that there's one of them. The point is that there's just Cl's, and they're on their own, and they're not attached to any further oxygens or sulfurs or anything. So MgCl2 is magnesium chloride because it's just chlorines, even though there are 2 of them. So let's step through this and have a bit of a review. Aluminum is the cation. It's the positive ion. It was in the +3 there, right? And chlorine is in the -1 column. That's why we need 3 of those and 1 of that, because that was +3 and -1. So what's the name? Well, we take the cation name, just the name, aluminum, and then double check. Is there more than one version of aluminum? And because it's in this +3 column, no, there is only one version. And so we don't need to say aluminum parentheses Roman numeral 3 because it's always +3. So we shouldn't have to say it. They can figure it out. So I'm not going to put Roman 3. And then there are only chlorines without any extra oxygens or anything, just chlorines. But there are 3 of them. That's not the point, but it's just chlorines. There's not a group of chlorines and other things as the anion on the right side being negative. It's just chlorines doing that. And so this is chloride. Polyatomic means many atoms. These are in the ion chart. Ba-doing. They just use the name that they have, but if we have multiples of them, we put them in parentheses. So here's a +2, and here's a -1, but the whole thing is -1, and I need to make this really clear because every year I have somebody who gets a little lost. And what I mean, that, I'll put it here, ClO3, that's 1 chlorine and 3 oxygens, that whole thing together is -1. And I have kids tell me, well, it's -3 because there are 3. No, the whole thing, the whole group, 1 Cl and 3 oxygens together in a box, so to speak, all together is -1. Now, the fact that we have a +2 and a -1 makes me need this. So I have Mg, that's +2, and the whole thing needs to add to be charged 0. Well, it doesn't add to be charged 0 right now. It adds to be +1, doesn't it? So I'm going to need 2 of these so that I can have -2 overall. And what we're going to do, I'm going to erase the little box. Box is just me talking to you. What we're going to do is sort of a modified box. We're going to do parentheses. This whole thing, I will have 2 of it. And now I have 2 things that are -1. Now I have +2 and -1, -1. And that is charge 0. And look, there's my printed out version. Chlorate. Now, pay attention. That is not chloride. It is not just chlorines. Then what is it? Well, that's why you have the ion chart, and it is alphabetized. So we're going to look for chlorate. Chlorate, ClO3 -1. That's what we had here. So ClO3 -1, except it has to add to 0 when we get done. Now, again, I'm going to do this wrong. I have kids say, oh, well, fine. Look, it's +1. That's not how it works. We said cobalt that is +2. That is officially cheating and wrong because that's not what you have. You don't have cobalt +1. You have cobalt +2. And chlorate is -1 because it is. It is a fact, and we don't get to fiddle around with that. But you could have more than one of them. You could have 2 of them. And now we have +2 and -1 twice. That adds to 0. Iron fluoride, iron 3 fluoride. So iron, that is a +3. Fluoride means it's just Fs, no extra oxygens or sulfurs or nitrogens. And F is in the -1 column. That's supposed to say -1 right there. That's the minus that got rolled up there. -1. And it needs to add to 0, which means I need 3 of these. +3 and -1 3 times is charge 0. Copper 2 chloride. Copper, that is +2. And chloride means it's just chlorines, which are -1. But it has to add to 0, so I will need 2 of those. nickel 4 nitrate. So nickel, now in Roman numerals, when the smaller number comes after, or in Roman numerals, when the smaller number comes before the bigger one, you subtract. So this is a 1, and that's a 5. But this is what you do. You do 5 minus 1. You subtract the smaller out of the bigger. So this is a 4. Yes, it's a dumb system. I have seen people mention that Roman numeral math is such a pain in the neck that it actually got in the way of their economy because doing the accounting was a nightmare. It's a very simplistic system that doesn't allow you to do quick math, and there is a reason it was dropped. Arabic numerals, base 10 numerals, are a huge improvement in calculating things. The one that you grew up learning, I'm saying. But this is nickel plus 4, and then we have nitrate. Well, what's that? Well, eventually you might remember, kind of, but we just look it up. And remember, this is on the right, which means it's the negative side. So we're going to look under the anions, and it's alphabetized. So nitrate is NO3 minus 1. But the charges have to add to 0, so I'm going to need 4 of all that so that I have effectively minus 4. Titanium 3 oxide. Need a blank there, don't I? Titanium. I don't know what that symbol is. Well, go looking. And it's positive 3. And oxygen. Well, what is oxygen? This will start to be something you remember too, but oxygen is in minus 2 column. So this is what we're dealing with, and it has to add to 0. So this is a little bit like lowest common denominator. Where do 2 and 3 meet on the number line? They meet at 6. Or if I said you had 2 and 3 in the denominator on fractions, what's the lowest common denominator? You would say 6. So what we'll do is make these both be 6. We'll make them be positive 6 and negative 6. How many plus 3s do I need? 2 of them. How many negative 2s do I need? 3 of them. And now this is a plus 6, and this is a minus 6, and they add to 0. I would read that through, ask me questions, ask your neighbor questions if they don't make sense to you. And let's try the other practice. Mercury, which is Hg because it's from the Latin, because people have known about mercury compounds for a long time, it is positive 2. And nitrate, which is NO3 minus 1. Where did you find that? On your ion chart on the back of the periodic table. Go look it up. Need to add to 0, so we will have 2 of that. 2 of this one. That's 2 minus 1s to balance out a thing that is positive 2. Now, here's another trick. It's not a trick, actually, we kind of review. But we said "ide" means like chloride and so forth, means there's just that element without any extra things. So magnesium, go look on your periodic table, is positive 2. And nitride means it's just nitrogen, so that is negative 3. So magnesium, that is positive 2, and nitride, that is minus 3, have to add to 0. Well, again, like I said before about the lowest common denominator kind of idea, what you can do is make them meet at a certain number, and 2 and 3 meet at 6. Or you know what you can do is you can kind of swap them like this. This comes here, and this comes here, and then some kid will say, you didn't swap them, that was a negative, you made it positive. Okay, but remember, these numbers down here are a count of the atoms present in this formula, and there can't be negative atoms present in a formula. And here's my example when kids start getting a little argumentative because they've had, a counting class or something, they're really good at math. Oh, I can have negative numbers. Why can't I? I want to use negative numbers. Okay, let me ask you this. How many pencils are in your pocket? The answer cannot be a negative number. It cannot be a negative number because we are talking about atoms that are in this formula. Once you hit 0, it is not possible to go farther. You can't have a negative number of pencils in your pocket. So potassium is K, it's positive 1. You look on the left side of your periodic table, go ahead, double check me. And that's called thiosulfate. And thio, by the way, is a root for extra sulfurs. So anyway, it's alphabetical. Look over here. Thiosulfate is S2O3, 2 minus or minus 2. S2O3 minus 2. Some kid says, it said 2 minus, same thing. Let's not argue about that. So this is minus 2 and that's plus 1. So we're going to need 2 of those so that I have 2 positives to balance out my negative 2. Chromium is a plus 3. And just sulfur? Well, sulfur on your periodic table is a minus 2. It's in your minus 2 column. So that's a minus 2. And again, lowest common denominator kind of idea tells me to take these across. So that's 2 of that and 3 of those. And then they add up to 0. So what's the name of this? Well, we're going to take just the name of the thing that's on the left. And it's chromium. And if you don't know, you keep looking, but it's here. And is it in a spot where the charges are obvious, like for aluminum or magnesium or something? No. So maybe it's obvious if we look on the back. No, it's not, because chromium can be positive 2 or positive 3. Okay, so we're going to have to tell the people because it's not obvious. If you say chromium, they won't know what you mean necessarily. So we're going to say chromium 3. And then we said if it's just some element and no extra things on it, then it's just ide. So this is going to be sulfide. Copper, that's plus 1. You'll learn that Cu is copper. Again, that copper is known anciently and is in the Bible and stuff, so it's from the Latin, cuprum. So it doesn't make sense in English really with the symbol here. And carbonate, well, let's go look up carbonate. And again, it's on the right side of the name, so it tells you it's going to be an anion. It's going to be negative, and carbonate is CO3 minus 2. But this needs to add to 0. So we'll have 2 of those, and there you go. Now, then some kid says, but we need parentheses. Well, I didn't make 2 groups of CO3. I just have the 1 group of it. So it looks really weird if you put parentheses 1. In fact, I don't know that I've ever seen anybody do that, and that is definitely the way to say, I'm new here. So I would not recommend it. What's the name? We just put the name, copper, put the name of the cation, and then we double check. Do we need to tell the people what charge this is? Look over here. Copper has 2 different versions, plus 1 and plus 2, so we will need to be clear about which type we mean, and we mean the positive 1 kind. So parentheses Roman 1, and then we just put the name of the anion, the negative ion there, so carbonate. Zinc, look on your ion chart. Zinc is only positive 2. Chromate, look on your ion chart, is CrO. I kind of forget myself now. It is CrO4 minus 2. That already matches in the charges you're saying. You're right, it does. So these already add to 0, so let's just leave it. We're done. What's the name? Well, we put down zinc. Look on your ion chart. How many zincs are there? Is there zinc 2 and 4 and 19? No, it's just zinc positive 2. So we will not be putting parentheses positive 2 because we shouldn't have to, because they can look it up. And if they're going to be using zinc in an ionic formula, they should be able to figure out that it's only plus 2. that they can use. So we won't put that. We'll just say zinc. And then we will just name the anion, because they can look that up too and find out the formula there and then match up the charges. Cobalt here has a positive 2 charge. And here is an exception to the little naming system. I know it seems like there's an exception all over the place, but hydroxide does not just have the one element. It is OH minus. And you're just going to have to get used to that. But it is under H. I did alphabetize it. So that's OH minus. And the charges need to add to 0, so we will have 2 of those. And there's your formula that adds up to charge 0. So cobalt, though, is just our name of the cation here. We just name it, and then we double check. Do we need to tell the people what charge it is? There are 3 versions of cobalt, so we very definitely need to tell the reader which version we're using, and we are using cobalt that is positive 2, and then the polyatomics here, just get the name, hydroxide. Hydroxide is not one element, it is 2 elements as a group. Sometimes there are 3 elements in a group. And silver is Ag. If you look up silver on your ion chart, it only has +1, as I mentioned before. And phosphate, hit pause, go look it up, is PO4 minus 3. This needs to add up to 0, so we will have 3 of the silvers. Remember, the 3 goes with the left. And now we have something that adds to 0. The name will be silver. Again, we just put the name, and then we double check, do we need to tell the people what charge is on the silver? And the answer is no, because silver only has a +1 type. So I'm going to do this wrong for a moment. We're not going to put that because it only has +1. So we shouldn't have to say, hey, it's +1. They can look it up. So I'm not going to put that. And then this part here just gets its name. So it's silver phosphate.